Hello class, this is Ms. Friggins with today's video on solving right triangles. So now you're going to be looking at problems that are going to ask you to solve a right triangle. And to solve means to find the unknown value. And you've been used to solving equations and things of that sort. But in algebra, but in geometry, when they're asking you to solve a right triangle, they're asking you to find all the measures of all the unknown sides and angles. So they may give you a side and they may give you an angle, but they're asking you to find the ones that they don't give you. And we can do that using a combination of either Pythagorean theorem, special right triangles, or trigonometry. So let's take a look. We already know how to find an unknown side using trigonometry, special right triangles, and Pythagorean theorem, but how about finding unknown angles? Well, that's where the inverse trig functions are important. We know the trig functions are tangent, sine, and cosine, and they take an angle and they give you a ratio. But what if I know the ratio and I don't know the angle? Well, that's where the inverse sine comes in. We indicate that we're trying to find the angle by the inverse sine symbol, which is, let me show you that one right here, which is, this means I'm trying to find the angle. So in order to find the angle, I need to know what ratio I have. So you put in the ratio and it will give you out the angle for the inverse tangent, for the inverse sine, and for the inverse cosine. So in this case, if I'm trying to find the measure of angle A, as you can see here in my angle A, but I know what BC is and I know what AC is, I can use the tangent ratio, because BC and AC are the opposite and adjacent legs respectively, to figure out what that angle is. And I'm going to show in the handheld calculators in class, it's real easy to figure out, but if you don't have a handheld calculator, I'm going to show you how to do that on another another type calculator. So the thing that's new today is this inverse trigonometry ratio, inverse trig functions, which instead of taking an angle and producing a ratio, they take a ratio and produce an angle. So let's look at an example. This is from the note-taking guides, page 1, and they say here, use a calculator to approximate the measure of angle 1 to the nearest degree. Well, here they've given me the legs, but they haven't given me the sides. They haven't given me the angle measurements. So I know based off angle A that CB is the opposite leg and AB is the adjacent leg, so I'm going to use the tangent ratio. And I know whatever the angle measurement of A is, I know that the tangent ratio measures 16 over 20, or 4 over 5 if I simplify it, or 0.8. Sorry. Okay, so how do I figure out what angle A is? Well, that's where we use the inverse tangent ratio. Since I'm using, so I take the ratio of 0.8 and I'm going to plug that into the calculator. And the calculator is going to give me what the angle is. So what I do in this calculator is I have to change this view from standard to scientific. And here they have this thing called the inverse. Okay, so I'm going to hit 0.8 and I'm going to do inverse. And as you can see, when I hit inverse, it gives me that little symbol for tan with the -1 in the thing. And I press that, and it gives me out an answer of 38.65, blah, 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 which actually is the same answer that they got over here. So I'll repeat that step, even though you could have just easily as rewind. But in this calculator, I hit inverse first because I want the inverse tan, and then I hit tan inverse. And then I plug in the ratio. Oh, sorry. You're supposed to plug in the ratio first. So I plug in the ratio first, hit inverse tan, and it gives me out the value. So that means that angle A measures approximately 38.65 degrees. Well, if I have angle A, and I already know that this is a right angle, which is angle B, I can figure out angle C by simply adding up the 38 and the 90 and subtracting from 180. Okay, so but if I don't want to, I can also use the tan inverse function to figure out C. So since I know that tan inverse of C is equal to 20 over 16 in my calculator, well, 20 over 16 is equal to 1.25, and I want to figure out the angle that produces that tangent ratio. I hit the inverse symbol, then the tangent, and it gives me 51.34. which I could have found another way by basically adding all these things up and subtracting from 180, but that's just another way that you do that. So that's how you find the angles using the inverse relationships. So let's take a look at the steps that you would do to solve an unknown triangle, to solve a triangle. First, you have to determine the unknown side length or angle measurements you are asked to find. Then you have to identify the given side lengths or angle measurements of the right triangle. Then you have to base your answers on steps 1 and 2, determine which trig ratio you use to find the values. So we did that when we knew we had to find the measure of angle A in example 1, and then we determined that we had the opposite leg and the adjacent leg already given to us in the triangle for example 1, and then we decided we were going to have to use the trig inverse, the tan inverse, to be able to find the values, and that's what we did, and then we solved it. And then we used other math, adding and subtracting, to figure out the other angles. If I wanted to figure out, for example 1, what AC was, I don't need to use trigonometry. I can use Pythagorean theorem because I have these two sides as well. So we're going to be practicing that in class, but the whole idea that I want you to take away with is the concept of the inverse trig ratios, which take a ratio and give you the angle that produces that ratio, and that will help you solve and find the unknown angle measurements of a right triangle.